Welcome to Level Chemistry, Unit 5, Day 2. So we are continuing on with our reactions unit. Before I begin our video for today, I want to give you a couple of reminders. If you took the Unit 4 covalent test and it did not go as well as you would have liked, please make sure you talk to your teacher about steps that you need to complete in order to remediate. So we are approaching the end of the semester, and it is going to be very important for us to make sure your grades are where you want them to be. So please talk to your teacher. With that in mind, we also want to make sure y'all are taking advantage of the extra credit project. If you go to Canvas, you will find this extra credit project and information linked on how you can earn extra credit. It is really fun and really easy. You can do an experiment and just submit a picture of the experiment. There is a whole module on Canvas, and it is titled DIY Labs Extra Credit. So check that out on Canvas. All right, enough of the announcements. We're going to get into our lecture for today. So what are we doing today? Last time we talked a little bit about the different reaction types. So today we're going to continue on and learn something called balancing. We're going to learn how to balance these equations. And if you recall from last class, we talked about the law of conservation of mass. So in order to comply with that, we have to do some balancing. Since matter cannot be created or destroyed, the number of atoms on each side of an equation must be equal. We have to follow the rules of the universe we're living in, so we're going to figure out how we can do this on our end when we're seeing these reactions. There are a few simple steps that you can complete every single time to balance a chemical equation. First thing you're going to want to do is write a coefficient. Now you might be thinking, what is a coefficient? That is the big number that you see in math and chemistry as well. It's the big number out in front. That is called a coefficient. We can't change subscripts. Those are the little numbers. You can't change those. That violates the law of conservation of mass. What you can change is the coefficients. And so that's what we need to do in order to balance. When you balance, there are different methods that work best for different students. And if the way you balance is slightly different, or you find another method that is different from what I'm going to show you, that's okay. As long as you can make it work. It doesn't matter exactly if your process is a little different from the one I'm going to show you. And I'm actually going to switch all over the document camera here in a second. I mostly work on what I call like the ping pong method, and it looks like a little ping pong table, if you can imagine that. But I also have linked the rainbow balancing video. If you're more of a visual person, that might work really well for you. And guess and check. So it's okay if you like a slightly different method as long as you get to a final answer that is similar to mine. Alright, so I've just switched this over to the document camera in order to show you how to balance. So, to begin with, you're going to notice we have Mg plus O2, and then we have a product that is magnesium oxide. So it's good to just kind of think to yourself, what type of reaction is this? And this is a synthesis reaction. I know that because I have two separate elements that come together to form a final product. So that's just something to keep in mind. When we start to balance, I am going to use what I like to call the ping pong method I can show you, and also the guess and check. But really you just want to think to yourself, okay, in chemistry, wherever I see an arrow, I need to imagine that this is actually just like an equal sign. So I'm going to put an equal sign over there, and that will remind me that what is on the left side of the equation has to be equal to what is on the right. And then you can just start counting. So I'll show you the ping pong table over here. All right. So I'm going to write down an Mg, and I'm going to write down an O, and then I'm going to draw a little line. And then I want to just count on each side of the equation how many of each there are. So what do I mean by that? I mean, I want to look at the reactant side and the product side and count how many of each element. So I've got 1 magnesium over here on the reactant side, and if I look on the product side, there's 1 magnesium over there. So far these are the same number, so I don't need to do anything to change this magnesium yet. All right, so let's go to the next reactant, that is oxygen. On the left side of this equation, I have 2 oxygens, but when I go to the right side, there is only 1 oxygen. So this violates the law of conservation of mass. The law of conservation of mass says that the products and reactants need to be equal, and 2 and 1 are not the same number. Luckily, there's a really easy way to fix this, and that's by putting a coefficient. So remember I said we can't change subscripts, so I can't just add a 2 over there. What I can change is the coefficient. So that's a big number. Okay, so now I'm going to update my table. Now I have 2 oxygens, but I've also changed my magnesium. So remember, coefficients distribute to everything. So this has what I always tell my students is unintended consequences. It sounds like a bad after-school special, but it's just a reminder that when we change something at the front, a coefficient, it changes everything. So now I have 2 magnesiums as well. That means I need to go back to my other side and put in another coefficient for the magnesium so that on each side they are the same. So 2 and 2. And so when I go back and look, I don't need a coefficient in front of this oxygen, so I'm just going to put a 1. It's an understood 1. So if we tally up our final balances on my table, when I finish, I have 2 magnesiums on the left side, and I have 2 on the right side. I have 2 oxygens on the left side, and I have 2 oxygens on the right. So this is now balanced. Okay, so I just showed you the ping pong method. Now I'm going to show you the method that I more commonly use, and that is the guess and check method. This is a little more freestyle. It's not as, I think, complicated as this ping pong method, but some students really enjoy the ping pong method because they like seeing how everything happens. It's up to you. Mine is more of a guess and check, which is just counting, looking and counting. I just kind of keep mental track of what's going on my left and right side. Okay, so I'm going to go through and look at each element and just count. On the left side, I have 1 calcium. There is no subscript there. Whenever there is no subscript, we assume that it is 1. On the right side, I have 3. Those are not the same number. All I have to do to make them the same, though, is put a coefficient in front of the calcium. So now I'm going to guess and check. All right, I've got 3 calciums on the left, and now I have 3 calciums on the right. Okay, so far so good. Let's look at the next element. On the left side of the equation, on the reactant side, I have 1 phosphorus, but if I look on the right side, I have 2 phosphorus. Those are not the same number. Once again, I'm going to use a coefficient to fix that. I put a coefficient of 2, now they are equal. And then at the end, I want to make sure I also include my coefficients of 1, because you do need to write them. And then we can check finally at the end. All right, so here's how I'm going to check. I want to make sure that both sides are equal. All right, on the left side I have 3 calciums. On the right side I have 3 calciums. On the left side, I have 2 phosphorus. On the right side, I have 2 phosphorus. So we are all checked. And just to take note of the reaction type, even though it's not asking me that in this problem, this is a synthesis reaction, just like the first one. All right. So it's up to you if you like ping pong or if you like guess and check. And I'm also going to include a link to the rainbow balancing method because you might like that one more. It really depends. The most important part is that your final result, you want to make sure the left and right sides are equal. Okay. So once again, I'm going to go with, I'll show you again the ping pong method. And we're going to just list out in this reaction what's there on both sides, the left and the right. So this is my left side, and I'm going to just start listing out my totals. On the left side of this equation, I have 2 nitrogens. On the right side, I only have 1 nitrogen. Okay, let's keep going. Now let's go to our hydrogen. On the left side, I have 2 hydrogens. On the right side, I have 3 hydrogens. 2 and 3 are not the same. So our hydrogens, we need to put in a coefficient, and we also need to do something with our coefficient to make the nitrogens equal. So none of this is balanced so far, but that's not a problem. We can fix this pretty easily. So when you're looking at this, we want to think, what is something that we can multiply these two together? Remember, because coefficients multiply, so we have the same amount on each side. So in the case of hydrogen, that is going to be, we want our total to be 6. Just multiplying 2 and 3 together, that equals 6. So here we go. On the left side, and it doesn't matter if you start with the nitrogen first or the hydrogen, that's not really important for this type of problem. Next time we are going to talk about one situation where it is important, but it does not matter where you start for these types of problems. So I'm going to just start with the hydrogen just because I was thinking about it. So I need to make this a total of 6 because that is the way we can balance 2s and 3s. So if I'm looking at that, remembering that it's multiplication, I'm going to write in a coefficient of 3 because 3 times 2 is 6. So I'm going to update my total on my ping pong table. 3 times 2, now I have 6 on the left side. And I'm going to go over to the right side. Once again, I need to make this equal to 6, so I have to think about what could I multiply 3 by in order to make it 6. 3 times 2 will give me 6, so I'm going to put in a coefficient of 2. And then when you think about how that multiplies out, we're going to update our totals. Now I have 6 hydrogen on the right side as well. Okay, so once again, I've got an unintended consequence. The 2 coefficient distributes to everything. So whereas before I only had 1 nitrogen, now I have 2. But that's actually okay because look at my left side of the equation. I had 2 over there, so I had to balance that anyway. So sometimes unintended consequences work in your favor. Okay, so I just need to put in a coefficient of 1 right here, because both sides are equal. And what you want to make sure if you do the ping pong method is that the final column, you want the numbers to be the same. So 2, 6, 2, 6. So that means I have now 2 nitrogens on the left side and 2 nitrogens on the right side. I have 6 hydrogens on the left side, and I also have 6 hydrogens on the right side. I am balanced. Everything is good here. All right. Let's take a look at the next problem, and now I'm going to switch back to the guess and check method. So once again, it really just depends on your personal preference. So I'm going to take a look, and see if I can kind of guess and check. Okay, so I'm looking at all the pieces of my equation, what's on the left and what's on the right. It's helpful, again, to turn it into an equal sign. Okay, so on the left side, I have 2 coppers. And on the right side, I can see that I only have 1 copper. So right away, I know I'm going to end up having to do something with that copper. Before I complete this, though, I'm just going to kind of look at what else I have going on here. All right, so oxygens on the left side, I have only 1 oxygen, but on the right, I have 2. So that's another thing that's going to get fixed. Just keeping tally of it with the guess and check method is a little less formal. It's just kind of looking at it and counting. So I know I have to fix the coppers. I know I'm going to have to fix the oxygens. And now let's look at the final element, and that is carbons. On the left side, I have 1 carbon, and on the right, I also have 1. So the carbon, so far, is not something that has to be fixed. All right, let's start working through it step by step. I'm going to begin by fixing my oxygen. Once again, it's okay if you don't start in the same spot. What matters is that your final product is in the end is the same. So on the right, I have 2 oxygens, but on the left, I only have 1. I'm going to fix this by putting in a coefficient of 2. So now I have 2 oxygens. They're equal on both sides, on the left and the right, but this had an unintended consequence. Because now I also have that coefficient going to the copper. So now my total coppers, I have 4 on the left side, but I only have 1 on the right side. Once again though, no problem, I can fix this with a coefficient. So I'm going to put in a coefficient of 4 because 4 times 1 is 4. And so once again, you just think, okay, I'm going to go back, I'm going to check. 4 coppers on the left, 4 coppers on the right, 2 oxygens on the left, 2 on the right, and now I'm good to put in my coefficient of 1 for each carbon. So everything in the end, if I'm looking at the left side and the right side, I'm looking at the total amounts of the elements. 4 coppers, 4 coppers, 2 oxygens on this side, 2 oxygens on that side. 1 carbon on the left, and 1 carbon on the right. This equation is balanced. Okay, next one. Once again, I'm going to do my guess and check method, and we're going to go a little faster on this one. So on the left side, I have 1 sodium. On the right side, I have 2. So right away, I can see this is something that's going to have to be fixed. I need to make them equal. I'm going to do that by putting in a coefficient of 2. So on the left, I have 2 sodiums. On the right, I have 2 sodiums. On the left side, I have 2 oxygens, but on the right side, I only have 1 oxygen. Okay, so what I'm going to do to fix this is put a 2 over here. Uh-oh, I just messed up this coefficient right here though, because remember, unintended consequences. Coefficients go everywhere. So I need to update this coefficient because now on the right side, I now have 4 sodiums. That's okay if that happens. That's okay. All you have to do is cross it off and write a 4 in there, or whatever your coefficient may be. Remember I said there are different methods for getting to your end product, and depending on where you start, it might make that necessary. So now, that's fine. Everything is good to go. 4 on the left, 4 on the right of the sodiums, 2 oxygens on the left, and 2 oxygens on the right. Okay, good job. So let's keep going. So, often polyatomic ions stay together. They stay together when they react. So we're able to keep them together and balance them as a unit. So don't ever break apart your buddies. I always told y'all, like, buddies stick together. That's true. Keep the buddies together. So if you see it in the parentheses, don't try and take it apart. We're not going to think of it as an individual. In this case, I'm not going to think of it as an individual sulfur or 4 individual oxygens. I'm going to think of it as one unit of sulfates. So it's 1 sulfate. That makes it really easy. So don't make your life harder and try and balance them separately. Keep your buddies together. All right. With that in mind, let's keep going. Okay. So I'm just going to do my guess and check method because that is my preferred method. Your preferred method may vary, but I'm going to use this guess and check method. So on the left side, I have 1 iron, but on the right side, I have 2. So right away, I know I'm going to need to put in a coefficient to fix that. I'm going to kind of look around this equation and see what else might need to be fixed. On the left side, I have 2 hydrogens. But on the right side, I also have 2, so that's okay. However, my sulfate right here is going to be a problem because on the left side, I have 3 sulfates, right? You see that 3? Remember, our buddies stick together. So that 3, that's what I'm going to say is the amount of sulfates. But on the right side, I have 3, and on the left side, I only have 1. So I'm going to fix this by putting a coefficient of 3. I'm going to go ahead and just start there, because why not? So now I have 3 sulfates, but unintended consequences, I also altered my hydrogens because that distributes. So 3 times 2 is 6. So now I need to fix my hydrogens on the right side, because on the right side, I only have 2 hydrogens. So what can we do? Just put in a coefficient. We need to make it multiply out to equal 6 total. Right now we have 2. 2 times 3 is equal to 6. So I'm going to put in a coefficient of 3. Okay, so my hydrogens are balanced. I've got 6 and 6. My sulfates are balanced. I have 3 on the left and 3 on the right. The only thing that I need to finish balancing out is the iron. On the left side, I have 1 iron, but if I look on the right, I have 2. So easy fix. Just going to put in a 2. And then to finish off my problem, I'm going to put a coefficient of 1. So all my coefficients now, everything is equal on both sides. Remember, you just want the total of each element to be equal, and don't break apart your polyatomic ions. Okay, let's keep going. So once again, be on the lookout for polyatomic ions. Okay, so we see this NO3 over here, but we've got 3 of them on the other side. We don't break them up as individual oxygens or individual nitrogens. We just treat them as a unit. So I have 1 on the left side and 3 on the right. Let's just kind of see what else is going on in this problem. I'm going to start with the borons. On the left side, I have 2. On the right side, I only have 1. So that is also going to need to be changed. Let's look at the bromines. On the left side, I have 6. But on the right side, I only have 1. Wow, so that's a big change. We have to change a lot of things here. So let's just start with, once again, it doesn't really matter where you start in any type of reaction aside from combustion, which we're going to learn about next time. This is a double replacement reaction, so it really doesn't matter which one you want to start with. It's up to you. I'm just going to start with the bromine because it's such a big change. So on this side we have 6 on the left. On the right side we only have 1. So I'm going to fix that with a coefficient of 6. Okay, but this also had the unintended consequence of changing my hydrogens. So now I also have 6 hydrogens on the right side, but on the left side, I only have how many? Just 1. So how are we going to do this? I need to make this hydrogen right here have a coefficient of 6 in the front of it. We have another unintended consequence, right? Because now we've also affected my NO3s. Now I have 6. On this side, we have 3. So we're going to have to alter our NO3s to make 6 on each side. We can do that by putting a coefficient of 2, because 2 times 3 is equal to 6. 2 times 3 is equal to 6, but this also changed my boron. So before I only had 1 boron, now I have 2. But like I said, sometimes unintended consequences work out in your favor, because look on the other side. There are 2 borons. So I actually solved one of my other problems. Now at the end, part of guess and check means you have to check. So you're just going to count on each side, left and right, and make sure. Go through every element and list them out if it helps you. On the left side, I have 2 total borons, because 1 times 2 is 2. And on the right side, I also have 2. So those are the same. Check. Now let's look at the bromines. On the left side, I have 6 bromines. And on the right side, I also have 6. 6 and 6. Check. We're good there. How about our hydrogens? On the left side, I have 6 hydrogens. On the right, I also have 6. Good. Balanced. And now my NO3s. On the left side of this equation, I have 6 NO3s. Remember, we treat them as a unit. Don't break them up into nitrogens and oxygens. And on the right side, I also have 6, because 2 times 3 is 6. So this one is balanced. Good job. See how much easier it is when we keep our polyatomic ions together? Makes it a lot simpler. Okay, so once again, we don't want to break apart the polyatomic ions. So we have 1 sulfate here on the left side. We have 3 on the right. I'm going to go through the rest of my equation and see what else needs to be updated. Okay, we're going to start with the borons. On the left side, I have 1. On the right, I have 2. So that's going to need to change. And if I'm maybe just going to go ahead and start and just see how we end up. We may need to go back and scratch something out if it goes a different way, but that's okay. It's okay. Students sometimes get worried. It's okay. As long as you update your totals at the end, it's okay if you have to change things a little bit. I'm going to go for it and just start. Okay, so now my borons are equal, but I've changed the amount of fluorines. So that 2 distributes, so I have to think to update my fluorines. I have 2 times 3, which equals 6. So I'm going to go to the other side of the equation. On this side, on the right side, on the product side, I only have 1 fluorine. We're going to solve that with a coefficient. Okay, so my coefficient here, because I have 6 on the left, I also need to make 6 over here. I only have 1 so far, so I'm going to put in a 6. All right, so 6 fluorines, but this also changed my lithiums. So now, on the product side, I have 6 lithiums. Now let's look back at the reactant side. So far, I only have 2. So what can I do to get this 2 equal to 6? Because we need an equal amount on both sides. Just put in a coefficient. And put in a coefficient of 3. And then I'm going to say, okay, this distributes unintended consequences. So now I have 3 times 2, which is 6. So my lithiums are good. But that changed my sulfates. I have 3. But that's exactly what I wanted because there's 3 on the other side. So sometimes those unintended consequences help you out and save you some time. So now each side is equal. What's on the left and the right is equal. So you're in good shape. Like I said, it's okay if you're somebody who really likes writing out the ping pong table. It's okay if you're more of a guess and check kind of student. As long as at the end, the left and the right side are equal, you're just fine. There are many methods. It is also okay if you have to cross out if you started balancing somewhere and then later on you realize your totals need to get updated. That is okay. Just need to make sure at the end that the number of each element is equal. All right, so we're going to do our homework now, and we'll see you in that next video.